Automation, it really feels like a magic wand sometimes.
Oh, absolutely. It's the dream, right?
Yeah, I mean, you have this massive, complex software platform. You point a robot tester at it, and you just tell the robot to click every single button on the user interface.
And you just sit back and relax.
Exactly. You sit back thinking you've just cast this spell for perfect system health. But if you actually do that, you aren't casting a spell at all.
No, certainly not.
You are engineering a massive, throbbing headache for yourself and, well, your entire development team.
A very expensive headache, yeah.
Right. So today, we're bringing you, our listener, into the room with us to unpack exactly why that is.
Because it's a huge trap.
It really is. We have a stack of sources today, specifically a slide deck from the Platform Foundation Academy, and it focuses on ServiceNow's automated test framework.
Which we'll probably just call ATF to keep it simple.
Yeah, ATF's way easier to say.
Yeah.
So our mission for this deep dive is to completely demystify test automation for you.
Which is so needed, honestly.
We want to define exactly when to use this tool, how to build tests that actually make sense, and, how to maintain coverage without losing your mind during a major platform upgrade.
Right, because that magic wand misconception you mentioned, it is arguably the biggest trap in test automation right now.
Oh, for sure.
You give a team access to ATF, and their immediate reflex is just to, automate the universe.
Just automate everything. Yeah.
Exactly. They try to script every click, every scroll, every little visual hover state on the screen.
Right.
But to use this framework effectively, we have to define its actual boundaries. There's a very strict dividing line between what ATF is built to handle and what it's fundamentally not designed to do.
Well, let's just draw that line in the sand right now then. What is the actual sweet spot for this framework?
So the primary target is the functional testing of business logic.
Okay, business logic.
Yeah. That means validating the actual gears turning behind the scenes of an application.
Can you give an example of that?
Sure. So say you submit an IT request for a new laptop. You don't use ATF to check if the submit button is like a specific shade of blue.
Right. Nobody cares about the blue.
Exactly. You use it to verify that once the request is submitted, it automatically routes to the correct manager for approval.
Oh, I see.
And that the inventory database updates correctly and, an email notification is actually generated. That is business logic.
Okay, that makes total sense.
It's also the ideal tool for regression testing.
Right.
So ensuring that when you roll out a brand new HR application, it doesn't accidentally break that existing laptop request workflow.
Right, because things get so tangled. I also noticed in the sources that it's highly recommended for browser compatibility testing, and it integrates with Jasmine.
Oh, yeah. The Jasmine integration is huge.
Yeah, and for anyone not deep in the code, Jasmine is basically a behavior-driven development framework for JavaScript.
Right.
It essentially lets developers write code tests that read almost like plain English sentences.
Which is super helpful.
Yeah. So if a team already has this massive library of JavaScript tests written in Jasmine, ATF allows them to bring those directly into the platform environment and run them natively.
Instead of starting entirely from scratch, yeah. It bridges that gap perfectly.
That's a massive time saver.
It is. But the flip side of this framework is the not recommended list, which is arguably even more important than the sweet spot.
Okay, lay it on me.
First rule, and this is non-negotiable, ATF should never, ever be run in a production instance.
Yeah, that seems like a pretty obvious red flag.
You'd be surprised.
Like, you definitely don't want a robot generating thousands of fake IT tickets while your real help desk team is just, trying to do their jobs.
Right. It clutters live data. It triggers actual alerts to real people. It's a mess.
Yikes.
Additionally, ATF is not a load testing tool.
Okay, so it's not for stress tests.
Exactly. If you need to know how your servers respond when, say, 10,000 employees log in simultaneously during open enrollment, you need dedicated performance testing software for that.
Because ATF just simulates individual user journeys, right?
Right. Individual journeys, not massive server strain. But the restriction that really throws people off is the one you actually mentioned at the start.
The UI clicking.
Yes. It is not intended to test every single UI component.
Okay, I have to play devil's advocate here for a second.
Go for it.
If I have an automated robot that doesn't need to sleep, it doesn't get bored, it doesn't ask for a paycheck, right? Why shouldn't I just script it to click every single drop-down and checkbox on the screen?
Wow.
Like, even if it takes a while, isn't it better to be absolutely safe? It kind of reminds me of hiring a highly skilled private detective to investigate corporate espionage, But then telling them, hey, while you're in the building, just walk floor by floor and make sure every single office light bulb is working.
That is a brilliant analogy. And look, you could have the detective check the light bulbs,
Sure.
but you are wasting their specialized skills on a task that yields, honestly, very little structural value.
Right.
And when we look at the actual mechanics of test execution time, your robot might not need to sleep, but your development cycle definitely does.
Oh, that's true.
User interface testing is incredibly slow.
Because of how web browsers actually work.
Precisely. To test a single UI element, the server has to send the HTML, the browser has to parse the CSS, render the visual DOM elements, and then execute all those client-side scripts.
That sounds exhausting when you list it out like that.
It is. Each click takes seconds. So if you have a test suite clicking 500 buttons, a simple test run takes hours.
Wow, hours.
Yeah. And when developers are trying to push an urgent security patch, they absolutely cannot wait 4 hours for the automated test to finish clicking light bulbs.
That completely puts the brakes on everything.
Exactly. By contrast, a server-side test just fires the code directly against the database in milliseconds.
Milliseconds. It's a huge difference.
So the true power of ATF is testing that underlying business logic quickly, not the cosmetic interface.
Okay, so we've established the boundaries here. We are aiming at business outcomes, not interface clicks.
Right.
But, knowing what to target doesn't mean we just dive in and start writing code.
No, definitely not.
The foundation of all this is the blueprint. Before a single test is built, teams really have to sit down and make a comprehensive plan.
And planning in this context, it means asking some really difficult questions about the life cycle of your tests.
Like what?
Well, a test is not a static asset. When the business decides to change how laptop requests are approved next year, your tests will fail because the underlying logic changed.
Oh, right. Because the test is looking for the old rule.
Exactly. So you have to plan for who maintains that test and how you identify common functionalities across your system so you aren't writing the exact same login sequence 100 different times.
Which sounds like a nightmare.
Yeah.
And the planning phase also brings up a reality check about coverage, right?
Yes, big one.
You have to figure out how to track the features you physically cannot build a test for in ATF.
Because there will always be untestable features.
Exactly. Maybe a specific workflow requires an integration with a legacy third-party vendor system that sits behind a firewall ATF can't even reach.
Yep.
Or maybe it requires a physical multi-actor authentication token, like a key fob.
ATF definitely can't press a button on a physical key fob.
Right. So you need a system outside of ATF to document those gaps.
Yeah.
If you don't do that, your dashboard shows 100% test passing, and you just assume the whole platform is perfect.
Which is terrifying.
It is.
Yeah.
Because you are completely blind to the external integration that is quietly failing in the background.
That false sense of security is super dangerous.
Right.
It requires a really deliberate strategy to avoid.
So what's the strategy?
The core of that strategy, like the overarching philosophy for designing these tests, is the KISS principle. Keep it short and simple.
Keep it short and simple. Which, that sounds like pretty generic advice until you understand the specific mechanism of how the automated test framework actually handles failure.
Right. It's not just a cliche here.
Yeah, because if an ATF test encounters an error, it doesn't just log the error and move on to the next step, does it?
No, it stops completely. All subsequent steps are immediately skipped.
That feels like a massive constraint.
That is the critical constraint. Imagine you build this massive, sprawling test with 50 steps to check an entire HR onboarding process.
Okay.
If it fails at step 3 because of, a minor typo in a user role, the entire test aborts.
So you have no idea what happens after step 3?
None.
Yeah.
You have no idea if steps 4 through 50 are actually functioning. So you have to fix step 3, rerun the entire slow sequence, and just wait to see if it fails at step 4.
Oh, man. That turns debugging into an agonizing, iterative nightmare.
It really does.
It makes me think of like an intricate setup of falling dominoes.
Oh, I like that.
You spend hours lining up hundreds of dominoes in a beautiful pattern. But if the third domino is accidentally glued to the table, the first 2 fall, they hit the glued one, and everything stops dead.
Yeah.
You could have 20 more glued dominoes further down the line, but you are completely blind to them because the chain reaction stopped.
Which is exactly why granularity is the solution. Instead of one massive chain of 50 dominoes, you want 10 independent chains of 5 dominoes.
Oh, that makes so much sense.
Shorter, granular tests act independently. If one short test fails, the other 9 still run.
Right.
So you immediately get a much wider, more accurate picture of your system's overall health because you aren't masking those downstream errors.
And this circles back perfectly to what we were just saying about the UI being so slow. The most efficient blueprint utilizes the UI very sparingly.
Yes.
You test a feature in the UI just once. So perhaps testing the actual interface of the laptop request form to ensure the submit button triggers the script.
Just to make sure the button works, yeah.
Right. But if you have 5 other test cases that require a laptop request to be submitted, you bypass the UI completely and use server-side steps to generate that request.
Exactly. You rely on the server for speed and repetition. The focus has to remain on outcomes, not data configuration.
What do you mean by that?
Well, you shouldn't be writing tests that verify if the description field contains the exact phrase, need new computer.
Okay.
You write a test to see if submitting an item from the hardware category successfully changes the state of the parent record to awaiting approval. That's the outcome.
Got it. Okay, so we have our blueprint. We are building short, independent domino chains. We are prioritizing server speed over UI clicks, and we are focusing on business outcomes.
That's the recipe.
Let's talk about the physical implementation now. Because even with a perfect plan, you can build a test that essentially lies to you with a false positive.
Oh, yes. It happens all the time.
And from the sources, it looks like the biggest trap here involves impersonation.
Impersonation is the very first thing you must address when building a test. The standard procedure is to always add the create user and impersonate test step first.
And what happens if you forget to do that?
If you don't do this, the test framework defaults to executing the steps as the user who clicked the run test button.
And the person clicking run test is almost always a system administrator, right?
Exactly. The system admin holds the master keys to the entire platform.
Right.
They bypass standard security restrictions, view rules, and access controls. So if an admin runs a test to see if an incident can be closed, it will almost certainly pass.
Because they have permission to do literally anything.
Right. But when a frontline help desk worker tries to do the exact same thing in the real world, they might be blocked by a role restriction.
Oh, wow.
So the test gave you a false positive because you evaluated your security from the perspective of an all-powerful user.
That is so risky.
It is. By using the impersonation step, you force the framework to create a temporary generic user profile with specific restricted roles and run the test through their eyes.
It's basically the difference between testing a bank vault security while holding the manager's override code versus testing it as a regular customer walking in off the street.
That is a great way to put it.
You have to restrict your own access to know if the system actually works for normal people.
Precisely. Now, aside from impersonation, another crucial implementation tactic is utilizing custom step configurations.
Okay, tell me about those.
The framework allows you to use a run server-side script step where developers can just write custom code to do whatever they need.
Very flexible.
Right. But if you find yourself writing the exact same code in multiple tests, say a script that calculates a specific business date, you really should package that code into a custom step.
Oh, because if the logic behind that date calculation changes in the future, you don't want to hunt down 50 individual server-side scripts across 50 different tests just to update the code.
Exactly. If it's a custom step, you update the logic in one central location, and all 50 tests inherit the fix instantly.
That drastically reduces maintenance overhead.
Drastically. And that same logic applies to managing test data using variables.
How does that work?
You can use a record query step to find a specific record in the database and then store a value from that record as a variable.
Okay.
If you need to input that value in multiple subsequent steps, you just reference the variable. So if the underlying data changes later, the variable updates automatically, saving you from manually rewriting hard-coded values throughout your entire test suite.
That is brilliant.
Yeah.
Now, I want to dig into a paradox that really stood out to me when we were analyzing how ATF interacts with the database.
Okay, which one?
The framework has a step called record update, which does exactly what it sounds like, right? It attempts to change data on a record.
Right.
But the mechanics behind it are just fascinating. A record update step can appear to pass successfully, even if the database record itself was never actually changed.
Yes. That trips up so many people.
That completely blew my mind. If the record didn't update, how on earth does the test pass?
It passes because of how the framework communicates with the platform architecture. When ATF executes a record update step, it is essentially sending a request to the server saying, please change the state of this incident to closed.
Okay.
The server receives the request without crashing or throwing a syntax error, so ATF says, great, my job is done, message delivered, step passed. However, behind the scenes, the platform might have a data policy in place, perhaps a rule stating that an incident cannot be closed unless a resolution code is provided.
So the data policy quietly intercepts the request and rejects it.
Exactly. The database says no. But ATF already marked the step as a pass because the transmission of the request was successful.
Oh my gosh, it's literally like a delivery driver dropping a package at the wrong house.
Wait, so?
Well, the driver's scanner registers the barcode, the system pings the server, and the tracking app tells you the package was successfully delivered. Like the delivery process itself executed perfectly.
Oh, I love this.
But when you open your front door, there is no package.
Yeah.
The outcome failed, even though the action technically passed.
That is a perfect analogy. And the solution to that delivery driver problem is to force a verification.
How did you do that?
You must always follow a record update step with a record validation step.
Okay.
You attempt the update, and then you explicitly query the database to say, show me this record. Is the state actually set to P deployed?
So you never trust the transmission?
Never. You only trust the verified outcome.
Trust but verify.
I like it. And this actually ties directly into how ATF handles security policies, specifically access controls or ACLs, right?
Yes, absolutely. When you configure certain test steps, there is a hidden pitfall involving a little checkbox labeled Enforce Security.
And it's checked by default.
Checked by default, yes. This means the test will actively respect the access controls of the user it is impersonating.
Okay.
But if you uncheck it, the test completely ignores ACLs and forces the action through.
Which goes right back to the bank vault scenario. You're giving them the override code. Precisely. If your test is failing and you just can't figure out why, it is very often because Enforce Security is checked and the temporary user you are impersonating doesn't actually have the proper ACLs to perform that action.
Wow.
Whether you leave it checked depends entirely on what you're trying to validate, but just forgetting that the checkbox exists is the root cause of countless hours of wasted debugging.
I can only imagine. Okay, so let's recap where we are. We have short, granular tests. We are impersonating the right users. We are explicitly validating our database updates.
Sounds like a solid foundation.
Everything is built perfectly in our little lab. But a software platform is not a museum exhibit. It's a living ecosystem.
Very true.
Real humans start logging in, entering weird data, and breaking workflows. On top of that, the platform itself undergoes massive version upgrades. How do we ensure all this testing architecture survives real-world contact?
This brings us to what I consider the single most powerful strategy in test design: dynamic selection.
Dynamic selection. Walk me through it.
When you write a test, you need to provide it with input data. The instinctive but totally incorrect approach is to hard code that data. You tell the test, open an incident and assign it to test user Bob.
Which works perfectly right up until the day Bob leaves the company, his user profile is deactivated, and suddenly your test suite crashes.
Exactly. Your platform's business logic is functioning perfectly, but your test fails simply because the hard-coded data rotted.
Another false negative.
Yes. The superior method is to use dynamic selection at runtime. Instead of hard-coding Bob, you configure the test to query the database and randomly select any user who is currently active and has the iTool help desk role, and you impersonate them.
I really love this concept. It's basically like letting a controlled gremlin into your system.
A controlled gremlin.
Yeah. By injecting a tiny amount of randomness into your test inputs, you stop testing the sanitized, perfect, happy path. You start testing the messy, chaotic reality of your organization's actual data.
And let me tell you, that controlled gremlin will find edge cases you never even thought to script.
Really? Like what?
Well, imagine you have a complex approval workflow. You run it dynamically, and suddenly it fails. You dig into the logs and realize that the randomly selected user happened to have a blank manager field on their HR profile.
Oh, so the workflow didn't know where to route the approval.
Exactly. If you only ever tested with Bob, whose profile was meticulously configured by an admin, you would never uncover that logic gap until a real user with incomplete data hit it in production.
That is amazing. Dynamic selection finds the cracks in your data hygiene. It's brilliant.
It's a game changer.
So that handles the chaos of human data. But what about when the platform itself shifts underneath us? How do we survive a major platform upgrade?
The absolute golden rule of surviving an upgrade is establishing your baseline. You must execute and validate all existing tests before the upgrade begins.
Because if a test fails after the upgrade, You need to know if the new version broke it or if it was already broken 3 months ago and you just didn't notice.
Exactly. You have to know your starting point. And test maintenance is a continuous obligation. If your developers build a new feature module, but nobody updates the ATF tests to account for how that module interacts with older features, your test suite slowly becomes obsolete.
Tests that don't evolve alongside the platform just become useless.
Worse than useless, they become misleading.
To keep all this execution manageable, the sources outline some very specific architectural best practices to follow.
Yes, there are some great execution tips in there.
Running tests in parallel is a given to save time. But there is also a feature called screenshots mode, which you can set to enable for failed steps. What's the benefit there?
That feature is invaluable for client-side debugging. Instead of staring at hundreds of lines of text logs trying to visualize why a UI test failed, the framework literally takes a picture of the interface at the exact millisecond of failure.
So you can see the error message on the screen, just as a user would.
Yes, it saves so much time.
There is also a very technical but super vital note in the materials about pacing your server-side scripts. Sometimes a test needs to pause and wait for a background process to finish before moving to the next step, right?
Yes, and this is crucial. The standard instinct for a ServiceNow developer is to use the glide system command gfs.sleep.
Okay, but we shouldn't do that.
Do not do this in ATF. When you invoke gs.sleep, you are literally halting the entire server thread.
Oh, wow.
You are tying up platform resources and blocking other processes from running while your test does absolutely nothing.
That sounds really bad for performance.
It is. The framework provides a specific API call instead. snadf.automatedtestingframework.wait and then second.
That's a mouthful.
It is, but it's so important. This command yields the thread, allowing the platform to process other background tasks while the test safely pauses. It is fundamentally better for platform health.
That is exactly the kind of deep mechanism we need to understand. It's not just about making the test wait, it's about how the wait impacts the entire server environment. And finally, when you have hundreds of these carefully crafted tests running simultaneously, how do you prevent your test suite from turning into this chaotic library where you can't find anything?
Naming conventions.
Really, just naming conventions.
It sounds pedantic, I know, but when something breaks in production at midnight and you are staring at a list of automated tests named Approval Test 1, Approval Test Final, and Approval Test New V3.
Oh, I've been there. It's awful.
You are going to be miserable. You must enforce a strict syntax. The recommendation is to use the application initial, a colon, and the functionality.
So for a test suite, it might be like ITSM, incident use cases.
Perfect. And for an individual test, maybe CSM, resolve case.
It essentially creates an instant scannable table of contents for your entire architecture.
A strict naming convention is truly the only defense against structural chaos as your automation footprint grows.
Okay, so let's step back and look at the whole picture for you, the listener. We started by taking away the magic wand.
Ripped it right out of their hands.
Yep. We know now that ATF is a precision instrument for validating underlying business logic, not a blunt tool for clicking every pixel on a user interface.
Right.
We explored how to build short, independent test chains, or dominoes, so that one failure doesn't blind us to a dozen others.
We uncovered the absolute necessity of impersonating regular users to avoid admin-level false positives.
And we talked about the delivery driver trap, why you must always follow a record update with a validation query to ensure data policies didn't secretly reject your changes.
Trust, but verify.
Exactly. And we broke down how to survive the real world by releasing controlled gremlins through dynamic selection, avoiding server thread locks, and maintaining strict organizational hygiene to survive platform upgrades.
It is a massive shift in perspective from just, automating things to actually architecting validation.
Which brings us to the end of our deep dive today. But before you go, I want to leave you with one final thought to mull over, building off that idea of dynamic selection.
It's a powerful concept.
When you introduce dynamic selection into a test suite, when you simply ask the framework to pick a random, real employee to run a workflow instead of a sanitized test profile, the number of bugs and logic failures you uncover usually skyrockets.
It really does. It exposes everything.
Which points to a really uncomfortable truth. The framework usually works fine. The business logic usually executes exactly as written. The real enemy of platform stability isn't necessarily bad code.
Yeah.
The real enemy is the unpredictable, deeply flawed nature of human data.
Absolutely. The data is what breaks it.
So the next time you are looking at your own system, ask yourself this. How much of your current testing infrastructure relies on the fragile assumption that your user's data is perfectly clean?
That's a scary question.
If your workflows only succeed when every field is filled out flawlessly, are you really validating a resilient system, or are you just testing a fantasy? Think about that as you build your next blueprint.